Hey everyone, welcome back to Tensor's Title, your go-to channel for machine learning and AI projects. Today we are diving into something super exciting, which is emotion detection using neural network. Have you ever wondered how AI can analyze human emotions from text? Well, by the end of this video, you will have a working model that can classify emotions like happy, sad, angry, and more. We'll be building this project step by step, making it easy to follow and fun to implement. So grab your laptop and let's get started. So before we jump into the coding part, let's see what's going to be the workflow for our project. So we will start by importing the emotion dataset, and after importing the dataset, we will perform some data pre-processing, like removing the irrelevant stuff from the dataset, like the usernames or URLs and etc. After the data pre-processing, we will do the data analysis. In the data analysis, we will be doing balancing our dataset and many more. After the data analysis, we will split our dataset into the training and the testing datasets. And on the training dataset, we will train our neural network. And after training a neural network, we will evaluate our model on various matrices. And after the evaluation, we will deploy our model into the Streamlit so that the other users can use it online. So that's what going to be the workflow for our project. Now let's jump into the coding part. Let me just quickly create and activate our virtual environment for our project. Now, as you can see that our environment is active, we will import the necessary dependencies, which are the libraries for our project. So we will type pip install pandas, numpy, matplotlib, scikit-learn, implearn, tensorflow. Now, as our libraries are now installed, let's close the terminal. And we will now create a file app.ipynb. Now let's import the necessary libraries. We will be using NumPy as it is efficient for numerical computations and matrix operations and handling. And we will be using pandas, which will help us to handle the CSV file using data frames and making data manipulation easy. RE is a regular expression which we will be used to clean the text by removing the unwanted characters like URLs, mentions, and etc. And for the visualization, we will import the matplotlib. And then TensorFlow is an open source deep learning framework, so we will be using for training our neural network efficiently. From the TensorFlow, we will be importing tokenizer, which will convert the words into a numerical indices, which is essential for training a deep learning model. And then we will import the pad sequences. Pad sequences will ensure that all text input have the same length by adding zeros where necessary. And from the sklearn, we will import the label encoder for transforming the categorical labels like happy, sad, angry into a numerical values so that model can process them. And we will be also importing the train test plate, which will divide our dataset into the training and the testing set. Now we will import sequential, which will allow us to build a layer by layer deep learning model. In this, we will also be importing embedding layer, which will transform our word into a dense vector representation. And dense is a fully connected neural network layer. And LSTM is a type of recurrent neural network that will remember past information over long sequences. We will import dropout, which will disable some neurons during training to prevent the overfitting. And bidirectional will be used to improve the normal LSTM by processing text in both forward and backward directions. Batch normalize will normalize the activation of each layer during training. And for the optimizer, we will be using ADAM as an optimizer, which is an advanced optimization algorithm to adjust the learning rate dynamically. And to balance our dataset, we will be using the random oversampler. And counter will help us to check how many times each emotion appears in the dataset to ensure our model doesn't favor one class over another. Now let's import the dataset. So pd.readcsv, emotion.csv. Let me show you the dataset. So this is a dataset with two features. One is the text and the other is the label telling the emotions of the dataset. Now we need to pre-process the text to remove the noise from it, like URLs, mentions, and special characters. So we will create a function for that and apply it on the text feature of our dataset. So first we will convert the text into the lower cases for uniformity. Now first we will remove the URLs from the text. Now let's remove the mentions in the text. Now we will remove the hashtags. Now we will remove the irrelevant punctuations and numbers. And finally, we remove the extra spaces from the text. So that's it. Now we will apply this function on the text feature of the dataset. So this will ensure that our text is clean and ready for training. Since our emotions are also in the text format, so we need to convert them into numbers. For that, we will be using the label encoder. Now let me show you the dataset. So as you can see that our labels are now numerical in our dataset. Now let's check if our dataset is balanced or not. Let me show you through the graph. If some emotions have fewer samples than others, our model might struggle with those. So we need to fix that. So as you can see that our dataset is highly imbalanced. So to fix this, we will be using random oversampling to balance the dataset. Before that, let's first convert text into numerical sequences that our model can understand. We will use padding so that all inputs are the same length. Now let's balance the dataset using random sampler. Now let's check whether our dataset is balanced now or not. So let me just quickly visualize the dataset again. So as you can see that our dataset is balanced now. So now let's start building our model. So firstly, we will convert our dataset into the training and the testing sets. So we will be using train test split for splitting the dataset into the training and the testing set so that we can train and evaluate our model. Now let's train our model. So we will be using sequential, which will help us to create the layers of our neural network. So first we will create the embedding layer in which we will convert the words into the dense vector representation in which the input dims are the total unique words in vocabulary, and we will map each word to a 200 dimensional vector. By putting the input length equal to max length will ensure that all input sequences are of the same length. Embedding will allow the model to understand the relationship between the words. Now we will create a bidirectional LSTM layer. It will improve the understanding by learning from both past and future words. And then we will use the batch normalization, which will speed up the training by normalizing the output and will reduce the overfitting and ensure smooth training. And then we will use dropout. Dropout will randomly drop the 30% of the neurons so that the network will not be relying on the specific neurons. It will also help us to prevent the overfitting. Now we will create another bidirectional LSTM layer. This time we will not use return sequences. So it will output a single vector, which will be the file and LSTM layer before fully connected layer. Stacking multiple layers will allow the model to learn more complex patterns in the text. Now again we will use the batch normalization and the dropout. Now we will create a fully connected dense layer. So what it will do is that it will reduce the dimensionality and extract a high level features, and we will use ReLU to introduce the non-linearity. Then again we will do the final normalization to prevent sudden changes in distribution. Now here's the final output layer. This output layer will perform the multi-class classification. We will use softmax activation, which will convert the logits into probability distributions. The class with the highest probability is chosen as the predicted label. So our model is complete now. Let's run this code.
So now let's compile and train the model. We will be using Adam Optimizer as it is efficient for deep learning, and loss as sparse categorical cross entropy is used for multi-class classification. So now let's fit our model. We will be training our model for the 10 epochs with a batch size of 32. And validation split is equal to 0.1, which will reserve 10% of the training data for validation. As our model is now trained, let's evaluate our model on the testing set. So the test accuracy of 0.93 shows that our model is classifying the text efficiently. So now let's save our model. We will be using Joblib for saving our model, tokenizer and the label encoder. So as our trained model is now saved, let's start building the front end for our project. So we will create another file app.py.
So now let me just quickly import the required libraries for our project. So we will be using Streamlit for the front end for our project and Joblib for loading the model. Now let's load our model and the preprocessor. So now let's just quickly copy the preprocessing function from the app.ipynb so that when the user enters the text, it will be preprocessed by this function. And then we will create another function predictor which will predict the emotion of the text given by the user. So first we will preprocess the data which will clean the user's input, and after that we will convert our text into the sequence using the same tokenizer which we will use during the training, and after that we will pad the sequences to ensure that all the inputs are 100 token long. After that we will pass the input through the trained model to get the probabilities for each emotion, and then we will convert the highest probability to an emotion label. And now we will start building UI for our project. So first we will give a title to our project. So st.title emotion detection. Now we will display an instruction. So enter a sentence to analyze its emotion. Now we will take the user input. So we will create a text area to get the input from the user. And now we will create a button analyze emotion so that when the user clicks on this button, the text will be sent to the predictor function and it will return the predictions which will be displayed on the screen. So we will display the prediction through st.write predicted emotions. So this is the code for the front end for our project. Now let's see if it's working or not. So we will go to the terminal. Let's first activate our environment. So we in scripts activate. Now as our environment is active, we will write streamlit run app.py. Okay, so now let me just quickly copy the text from our dataset and let's check if it's predicting correctly or not. So as you can see that our model is predicting correctly. Let's check it again. So yes, our model is working fine. Okay, so now let's deploy our model. So first we will create a GitHub repository for our project. Let's go to our GitHub account and create a new repository. Let's name it emotion detection and click on create repository. Let's copy this code. Now first we will create a requirement file for our project. We will go to our terminal and activate our environment and then we will type pip freeze requirements.txt. So this is the requirement file for our project. So now let's initialize our GitHub repository. So git init. Now we will add all the required files into our GitHub repository. So git add app.py, tokenizer.jb, label-encoder.jb, requirements.txt, emotion model.h5. And then we will paste our code and press enter. So now as you can see that our files are pushed into the GitHub repository. So now let's deploy our model. Now we will click on deploy now, and then we will copy the app.py URL and paste it over here. So now let's name our project emotion detection 01 deploy. So our project is deployed. Now let's check if it's working fine or not. Let me just quickly copy a text and check whether our project is working fine or not. So as you can see that the model is working fine. So that's it for today's guys. If you like the video, do like, share and comment and subscribe to Tensor's Guidance for more exciting machine learning videos.